Hi, today let's check whether a linked list is sorted or not. We are given the head of a linked list and we need to tell whether this list is sorted or not. So let's take these examples. Let's say we have 1, 2, 3, 3, and 5. And on the other side we have 9, 7, 7, and 4. The important observation is that the list can be sorted in either of the direction, either increasing or decreasing, and also duplicates are completely allowed. Now, our approach is very simple. We traverse a linked list only once and we maintain two flags. One is non-decreasing and one is non-increasing. Initially, we assume both are possible. We start traversing the pointer from the first node. Let's say if we are traversing in this linked list, we have the pointer here, and we start traversing. Okay, and as we traverse, if the current value is greater than the next value, the list cannot be non-decreasing. And similarly, if current value is less than the next value, then the list cannot be non-increasing. So basically, it is like we have current dot data. If it is greater than next dot data, then it is not non-decreasing. And if current dot data is less than next dot data, then it is not non-increasing. So we just keep updating the flags while we move forward. And at the end of the traversal, if either one of the flags is still true, then the list is sorted. So what are the edge cases here? So if the list is empty or has only one node, it's already sorted. So we directly return true. Suppose we have an empty linked list or a linked list with just one node, we simply return true. And since we traverse the list only once, the time complexity will be big O of n, and we use constant extra space, so it's big O of 1 anyway. So let's now look at the coding part. All right, let's look into the coding part now. We defined a function called isSorted, which takes the head of a linked list as input. The edge case is the edge case that is to be kept in mind is if the linked list is empty or has only one node. So if the linked list is empty or has only one node, it means it is already sorted. That is, if head is none or head dot next is none, we simply return true because it is already sorted. So we directly return true without doing anything else in this particular situation. And now let's initialize the flag, say non-decreasing equals to true and non-increasing equals to true. Non-decreasing assumes the list is sorted in increasing order, and non-increasing assumes that the list is sorted in decreasing order. Initially, we assume both are possible. Now let us start the traversal. Current is head. We start traversing the linked list using a pointer called current, beginning from the head. Now, while current dot next, that is, we loop until the next node becomes none, because we always compare the current node with the next node. Now we gotta check if the linked list is non-decreasing. So for that, if current dot data is greater than current dot next dot data, as we already discussed, then the flag will be non-decreasing flag will be false. Okay. Similarly, we check for non-increasing order as well. If current dot data is less than current dot next dot data, then non-increasing flag will be false as well. Okay. After comparing, we move the pointer to the next node and continue the process. So it is current equals to current dot next. Okay. After traversing the entire linked list, if either non-decreasing or non-increasing is true, the list is sorted. So we return the result using OR condition, that is return non-decreasing or non-increasing. Okay. Okay, let's go ahead and run the code. As you can see, for the first test case, 5, 5, 6, 7, 8, they are actually in the ascending order and they are sorted. So we simply return true here. And in the second case, we have 2, 5, 7, 8, 99, and then 7. So this is not in a sorted order. So that's why we return false. Comment down your thoughts below, and thanks for watching.